Thank you. So, hello again. For those who have was here and watched my session yesterday, so we are continue the same approach because yesterday I showed you how to compromise different services like virtual machines, hybrid ID, PaaS services. And I promise you that we'll continue today, and I'm going to show you how to do the same with containers. Similar, of course, not the same. Similar thing with containers. So that was my promise to you. And so let's try that. As usual, once again, for those who watched my session yesterday, my session will be based on live demos. So you will not find a bunch of slides here. So I will probably show you some slides for basic information, to give you some basic information about most of the most interesting things will be provided on live demos. One last thing before we actually start. This session about containers and any session about what we call pentesting or hacking, usually based on not the really vulnerabilities of the service itself, because that's a cloud service. It constantly Microsoft managed that, add new patches, so you just need to switch simply to the new version. So we don't really talk about vulnerabilities of the service itself, because even if you can find some vulnerabilities in the service, they will be patched really quickly. What we usually cover, we usually talk about misconfigurations. So some sort of deployments that are maybe convenient, but not perfect from security standpoint. So that's the goal, is to show you not optimal configurations, not secure configurations. All right. So thanks for introduction that you already introduced me. I will just show it in the slide. If you have been here yesterday and you heard about me, so that's me again. If you haven't been there, so my name is Sergey. I do a lot in the security domain, and my favorite is something like offensive security. So I prefer to show how things may be compromised. And based on this information, my customers and students, they realize, oh, we have some misconfigured environments, so we should fix this and this. So that's convinced them to make the infrastructure more secure. If you want to contact me, here's the URL. Go ahead. We'll be happy to add you to my network. So let's get started. Before I just start talk about pen testing, I just want to say a few words about containers, because containers, it's pretty specific topic. If you are a developer, you know this topic pretty well. I bet you do. But what if you are a security engineer or you are IT professional? Maybe you don't have a lot of experience with containers, and all of those names like container registry, Kubernetes, container instance, you may not be really familiar with them. So what I want to do first, I want to explain you how container service in Azure work together on the slide. And then I will jump to demo and show you how we can compromise those things. So first, I'm going to show the slide. And I want to explain you like what I call containers 101. So first, if we want to run containers, and containers, just now it's one of the most popular way to deploy applications. So if you want to run container in the cloud, what we must do first, containers will be deployed from image. So we must create container image. Container image usually created using Docker. So that's the most popular tool environment to create container images. So we take our application dependencies, operating system pieces, and combine that in a single container image. So when we have image up, when we have image ready, we can run containers from there. But because we are going to do it in the cloud, so we must take a few extra steps. So first of all, if I want to make it cloud-based container, I must first push this image to container registry. That's a special service where images are stored. So before I can deploy the container in the cloud, I must make this image cloud-based. So I must push this image to container registry. And so this image will be stored in the cloud. So container registry, that's a storage for images, my private storage for images. And so after I have my image in container registry, I can deploy container from that image. And I can use one of two services. Service number one, which is more like dev and test, called Azure Container Instance. So we usually use the service to test something or for some small implementations. So that's the most common use cases for container instance, because it's very simple. You may just deploy that in a few clicks, but at the same time, you will not be able to make a lot of configurations there. So it's more dev and test. But you may run containers there, or which is much more popular, run containers in Kubernetes, Azure Kubernetes Service, or AKS. So Kubernetes, that's the service where we can run hundreds, thousands of containers. It will orchestrate resources and so on. So this is very common service to run containers. And so we'll focus when we will do pen test on this service. So I hope it's clear what's the difference between all of those container services. So registry to store images, container instance or ACI to run containers, but more like, they are more like isolated, independent applications. And Kubernetes, let's call de facto standard, where we run containers in production and we can run hundreds, thousands of applications there. So now when you know this information, let's start to pen test that. And the first what I want to show you, what we really like in the pen test is what's called quick hits or quick wins. So how can we compromise something in a few clicks? How can we find the shortest, like a shortcut to achieve our goal? If my goal, and once again, I will focus more on Kubernetes because I may have hundreds and thousands of containers there. So if my goal to compromise Kubernetes, let me show you the most simple way to do it. So I'm going to jump to demo as usual. Let me show you a few things. If when we talk about Kubernetes, companies, they manage Kubernetes with a tool called kubectl. So that's the very popular tool that we use to manage Kubernetes. Let me try to run this tool and let's say get pods, which is like applications in the terms of Kubernetes. I run that, and in parallel, I will do the same on different workstation. So here's working fine. So it shows me my pods. And here it doesn't work. So why it worked on one workstation and doesn't work on another workstation? The reason is because on one workstation here, on this workstation that I'm showing you now, I was authenticated. So I was authenticated, so that's why I can run this command. So you saw I did not authenticate right in front of you. I just opened CMD and just type a command. So looks like this token to access Kubernetes cached somewhere. So let me show you where this token is cached. If I go to users and go to my user profile, there is a folder called .kube. And here in that cube, you may find token. If I take this token, let me just zip it real quick. Copy this and paste in the same folder on the different workstation. Unzip it here. And fingers crossed. Yep. Now I do have access to Kubernetes. And so based on the permissions that user had, what I can do, I can run kubectl exec -it, and then the name of the node. Let's take front end. Copy this, and let me run shell. So I'm inside of the container. So here's the application. Let's see, for example, this one config file. And that's the voting up. You will see that later on. But you can see here, I'm inside of the container. Now I can have access to any container. Of course, it depends on the permissions I took from the token, but now I'm inside of the container. Yesterday, if you watch my session, Offensive Azure Security, you probably know how I can get access to profile of user to steal the token. I showed you how we can become the main admin, but that's a quick win for Kubernetes. That's a quick win. So let me jump back a slide. But quick wins, they are not super interesting for conferences. So we love them in the real pen test because we can finish our work very quickly. And you should know about them. But for the conference, let me show you something else, which will be a longer way to compromise the environment. And also, along the way, you will find much more misconfigurations that you may mitigate later on. So in my scenario, which will be the let's call it more interesting and more complicated. In my scenario, the main hero will be Azure Container Registry. So Container Registry, really? Yeah, and that's the typical misunderstanding of customers. So they really try to take care of Kubernetes because they know their containers are there, and quite often they forget about container registry security. So in Container Registry, if someone has access to download images, this user can download existing image from Container Registry. And then this user may trojanize, so put the trojan or poison this image. And if this user has permissions to upload images, this user may upload or push, what's called in terms of Container Registry called push. This user may push the poisoned image back to registry. So I'm gonna take the normal image, trojanize that, and push it back with the trojan. And then company will just normally deploy containers from that image, but the container will be trojanized. So that's what I want to show you next. And that's what you will see in the next 20, 25, 30, we'll see minutes. So I'm going to jump back to demo. And first, before I start to show you the actual pen test, I will show you what I have at this moment on the portal. So on the portal, I have Container Registry. It's called AZ Hack. And that's a full name, AZ Hack, AzureCR.io. And in this AZ Hack, I have one image. It's called Hello W, like Hello World. So I have one image in the registry. And also I have Kubernetes. And here on Kubernetes, I have one application which is running. And this application is super famous. If you ever work with Kubernetes, you know, I mean, not Kubernetes in general, but AKS, Microsoft version of Kubernetes, you know that Microsoft always recommend to try this application for test purposes, voting application for cats or dogs. So I have this application. I will back to this application later on. But that's what I have initially. That's what I pre-configured before my demo. All right, so now let's start to pen test. I'm going to go to different folder. Now what I want to do, I want to download container image. But before I download this, I must authenticate. So I must use this command, ACR login to hyphens name hack, which is the name of my registry. Let's try to do it. I expect to have an error. I mean, it will not be, yes. So it says, hey, you must authenticate first before you start to get into before you authenticate. So here, if I want to authenticate, so I need to have credentials. To do it, I will use the trick I showed you yesterday with another folder called .azure. So if I take this folder content, zip it, and paste here. And extract again. Let's try, fingers crossed. Now it should be able to authenticate because now I have at least read access to container registry, so it will be able to authenticate. Yep, I did. And now login will succeed. Now, when I was when my request was authenticated, what I want to do, I want to pull image. So I will use Docker pull. Sometimes it gives some there like this. Let's try again. So I will use Docker pull. So Docker pull will download the image locally, and Docker save will be able to save this image into file. So I expect to see the file like hello-org.tar. So that's going to be my container image in the single file. So let's go to this folder. And yeah, I have this file, which is this size. Let me extract that. And so now what I want to do, I want to trojanize this image. And before I do it, by the way, let me open Docker desktop. Docker desktop. Here we go. So now I have this image in Docker. Let me remove this. Now I have, I can see the image on the disk, and I want to trojanize that. If I go to any folder, I will find what's called layer tar in any folder. And if I open this layer tar, let me just open this one. I can find the folders there, like var, .dub, HTML, index.html. So that's the normal files there. And you know, it's Linux path. If I have the normal files, maybe I can add some other files there. Let's try to do it. If I extract a layer to the separate folder, what I can do, I can take my Trojan, which is a shared library, and this Trojan will be a reverse shell. This reverse shell in .so format, it means, if you're not really familiar with Linux, it's like a shared library in Linux, very similar to DLL in Windows. So I'm gonna take this folder, copy this, and place to it. And now what I want to do, I want to zip it again. But before I replace this new layer with my old layer with the new layer, what I want to do, I want to take the file hash of the old layer, PowerShell. So that's the old hash. Let me copy this. And what I want to do, I want to take the new layer and replace the old one with the new one. And let's take the hash again. And I have a new hash again. Copy this. So now I have old hash and new hash. Why? You'll see later. All right. Now I can remove this folder. So I add file physically, but this file will not do anything. It's just file on the disk. So I must tell the container image that this file must be preloaded, and some commands must run when container is loaded. To do that, I'm gonna open a JSON file here in the root of the container image, and you may find all the commands that will start when the container is running. And so what I want to do, I want to add something else. I want to add a command called ld preload. In Linux, it means that this library will load even before any other libraries, even before anything else. And also, I want to run. I will add some attributes. One attribute is the remote address. That's not the address of my Linux machine. And this one is the remote port, which is the port that I will use on my hacking machine. I almost done. One more thing. I must change the hash of the old layer to my new hash. As you can see here, there's 9b3 46 and so on. That's the hash. That's the hash I had before. What I must do, I must tell to this container image that my hash now is different. And so let me take this new hash. But the problem is it will not work. It will not work because my hash in the capitals, so I must convert it to string, lowercase. And so let me place it here. And that's it. I'm done. So I finish with modification. Now I just need to zip it. Let's call it hello troj. And right here. So now I should have at least. I'm not really sure that it's working, but we'll try that. I have the container, which is image, which is trojanized, and you can see here there's a 10 kilobytes difference between them, between original and trojanized. Now let's try to check if this trojan is working. So I will run the listener on port 4444. That's what I configure in my container image. And now let me load this image. First, it should load to Docker. Yep, it is. And now I just need to run it. Let's say Docker run, and we'll take this crazy name. One more thing, by the way, because this container is just an HTML file with the title "Hello World." It exposed port 80, but on my local machine, port 80 is busy, so I will map it to port 8080. So I will take port 80 of container and expose port and map it to my port local 8080. That's it. Let's try to run it. Let me check. Yeah, I have a listener. Let me run that. And look at this. Look at this. I have a shell, and I'm inside of this container. And if I go to HTML, I can see the index page here. Let me check what this index page is all about. It says hello W world. So let me try to go to port 8080 and check. Yep, hello W world. As we can see, my container image now is working, and my Trojan there is working either. So for users, it's still the regular application with a hello world page or whatever it may be. For me, as for attacker, that's the container with Trojan. All right, now So if I have this container, image, now what I can do, let me go back to my slide. So we are here. So I trojanize this container image. Now what I want to do, I want to push it back to a registry. Of course, I must have permissions to do it. But that's the goal of the session, to show you the bad configurations, and so what people can do if they can have those permissions. So let me jump back to my workstation, and here I want to push this image back to registry. It shouldn't take long because, as you can see here, a layer already exists, and just push the new layer. And let me go now to I can close this. Let me go to my registry, go to repository, and I still have the same image. So there's no it's not a second image. That's the same image. But if you look at the last update date, that was a minute ago in my local time. So looks like I'm all set. All right, so I'm here. I trojanize this image and I push it back to container registry. So now, normally I should wait before company will start to deploy applications regularly in Kubernetes or container instance, probably Kubernetes. And so I should get a shell to Kubernetes container or container instance. Of course, I will not wait here because that's my demo environment. I should initiate that. And so let me show you this. So first, I will use container instance, which is really good to for the test purposes and to just check if my image is working, my Trojan is working in the cloud. So I'm going to jump back to demo. Now I need to work with Portal. So interesting. I don't have any images, I guess, but no idea what's that. I have few guesses about this. Maybe that's vulnerability assessment service. Always try when I just push the image, it tries to establish a few shells. Maybe that's the VA solutions trying to simulate something. All right, so now we can continue. All right, now I'm going to first create container instance. And here I will call it ACI. I will take it. I can take what? Oh, West US. Why it's West US? West Europe. So now I can take the image from registry. Let's do it. Go there. So it will be public. Port 80 will be exposed. And click next. And let's click create. Now, if everything is fine, will be fine, I should get a shell to container instance. To be fair, I'm not really interested in container instance, because container instance usually is more like isolated. But I just want to check that everything is working fine here. And I can get a shell to cloud resource. Come on. That will take around maybe 30 seconds, minute, I don't know. So, container instance, that's something that creates pretty quickly, but it still needs some time before it will be created. Let me go there to resource group. Go there. And so let's monitor the progress. It says creating, so maybe I already have. No, not yet. Not yet. But I already have public IP address, so maybe not yet. All right, so it will take maybe a bit longer. And so when it will be created, I should be able to see the page, and I should have a shell. And cross your fingers that I will have a shell to this container instance. Wow. Why it's so long? Come on. Doesn't take that long. Let me go to containers. Still waiting. Refresh. All right, let's check that later. What I expect to see is container instance will have my container with Trojan deployed, and I will get access to container instance. But if I get access to container instance, I will be locked into single instance, which probably not my primary goal. So I will continue my fishing. Just waiting before someone will deploy that in Kubernetes. Of course, I will simulate Kubernetes myself, but Kubernetes should be able to give me more access, because on Kubernetes, I will have other containers running. All right, I guess we already have a shell to container instance. And yeah, as usual, let's see that it's working on the portal. Still waiting. I think I need to click refresh here. Yeah, it's running. Maybe it's working here. Maybe yes, maybe not. Close that. But if I go to var HTML, and yeah, that's the same index page. So now I'm in container registry, and so let me start container instance, not registry. And if I look who is this IP address should belong to Microsoft. Yeah, Microsoft. So that our Trojan is working, and it's working in the cloud as well. All right, now let's try to do it on Kubernetes. Let me remove this to make sure I don't have any other tokens. I mean, not any other attempts to connect from other services. Now, let's do the same on Kubernetes. I'm going to go to Kubernetes, and in parallel, I'm going to take, that in Kubernetes, we must deploy that from manifest. So I'm going to open my manifest I'm using to deploy this container. And go here. Of course, I can use kubectl, but this one, why not use Azure portal? So let me deploy this from manifest, and let me check that, yeah, my listener is working. Let me click add. Fingers crossed again. And yeah, now I have a shell to Kubernetes. And yeah, that's the same container, but this time this container is working on Kubernetes. So what I can do if I'm inside of the Kubernetes, first what I should do, I should add path variables. And what I want to do as well, I want to install a tool called curl. I will use this tool soon. So let's wait a few seconds. By the way, this shell is not super nice, and sometimes it will I will not be able to see the progress. I think the installation of curl should be fine. It should tell me done when in the end, hopefully it will. But sometimes I just need to check with different commands to make sure that it says done. So what I want to do first I want to check this token. Each container on Kubernetes has this token, and this token will be used to connect to storage. It's like service account token. So I can find this token on Kubernetes. And what I want to do, I want to add this token. To as a variable. Let me copy this. And damn it, let's try again. So now this token is added as variable. All right. So now what I want to do, I want to test my Kubernetes cluster. with this token. So as you can see here, I access the cluster with this token, authentication token. Let me run that. And now I can see APIs available on this cluster. So I can test Kubernetes cluster with this token. I can see a list of available APIs. So let's try something else. I can see many APIs. Let me go even deeper. Let's see if I can see pods. So no, it says failure and forbidden. So my service account token doesn't have enough permissions to list pods in the cluster. So I can list APIs, available APIs, but I cannot go deeper. So here, unfortunately, with the token I have, unfortunately or fortunately, who knows, depends from which side you are. For me, it's unfortunately, I can't move on with my token, with my service account. But maybe I can. So I cannot explore the Kubernetes cluster, so I cannot pen test the cluster itself. But maybe other containers will be available for pen testing, because I know that there are containers with Vulkan application. Maybe they will be available for pen test. Let's try that. So first, what I want to do, I want to install nmop, which is very well-known tool, port scanner tool. So let me install that real quick. And normally, what I want to do with nmop? With nmop, I want to scan the network and ports. I want to scan network and ports and find available containers. I would say normally it's not the best idea to just start scan the whole network with nmop, because it will take forever. Much better to use another tool called NetDiscover. You may also install that on Linux machine. And so NetDiscover first will find other addresses, other available addresses on the network, other containers, other IP addresses, and then scan those addresses with nmop. So don't start the scan of the whole network, as it will take forever. So I think it's finished. All right, so I installed nmop, and for the sake of time, I want to scan the address I already know. So it will be this address, 10.0.242.126. What this address is all about? This is the backend of my Vulkan application. And I can see here that port 6379 is open here. Let's check what this port is all about. So let's see, port 6379. And this is Redis. So in-memory database. All right, what I know about Redis, I know that I can this database in memory, but I can connect to it using Redis tools. So let me install Redis tools first. Shouldn't take long as well. That's it, I guess. Yeah. And now the last thing I want to do, I want to connect to Redis. And let's type info. Yep, I'm inside of the Redis. And now let me go to this application, Vulkan application. Now let's play a bit with application. I know here that in this application, when someone votes, data will go to Redis database. Let me first check keys, and I can see there are two keys, cats and dogs. Let's say get cats, and we have 0 cats. Let's say get dogs. We have 0 dogs. Let me vote for cats, and let's get cats again. And now I have 1 cat. So I'm here inside of this Redis database. All right, I want to ask you to do one more thing, dear TV watchers. I will type monitor, which will give me which will allow me to monitor all of your actions. So know when you vote, when you read the information. And I want to ask you to go to this website and just vote for cats or dogs. And you will see, and so right in front of you, you will see the activity. So I'm waiting and waiting. I can see one get, one vote. That's better. At least I'm talking to myself. Oh, looks like someone pressed reset. Am I talking to myself? Oh no. More votes. That's better. Oh, thank you. It looks like it was a delay between my words and your votes. So as you can see here, I can monitor what's coming into the database, and so now I don't want to say I own the database, but at least I own this data. So, and that's the end of this pen test. So I Trojanize the image. I run the container from image, and so that container gave me a shell, and from that shell, I get access to other containers. And so that was the second scenario: how we can compromise, how can we try to compromise Kubernetes in the cloud. So, let me close this. I want to run one more thing. Give me a moment. I'm going to run my Kali machine. And now let me jump to last slide, last informative slide at least. And on this last slide, I want to discuss with you possible mitigations. Yeah, as usual, my sessions, they are more offensive. So I describe their offensive things. But also what I want to do here, as usual, I want to briefly tell you about what we can do to mitigate all of this. And the first, how can we mitigate the first problem when I pull and push images? Mitigation number one, do not give those permission to everyone. Be really, really careful. Yeah, it's harder to get push permission, but pull, when someone can download image, it's super simple to get. I must be just a reader. Quite often those permissions are inherited, and so someone can get those permissions. So try to follow principle of least privileges. Try to provide the smallest amount of privileges to anyone, including administrators. So next one, private links. What is that? Private links, that's the way how can we communicate with some services using virtual networks only. So some PaaS services may communicate with other services only using private virtual network. So container registry, which is storage for images, may work only using private links. So you will not be able to push or pull images from outside. So you can do it if you enable private links, of course. You may deny public access, like we did that with database yesterday. And so it will be available only through virtual network, not from any IP address. If it doesn't work for you, what you can also do, you can whitelist public IP addresses. So what does it mean? It means that you can pull or push images only from specific IP addresses, public IP addresses, not from anywhere, only from specific addresses. That's all for container registry. Next one, when I install credentials, here the recommendation is the same as I gave you yesterday. So you may use the separate workstation or PAW. to administer Kubernetes. And so this workstation must be much better protected than the regular workstation. And also principle of least privileges. Even if someone steals token, this token should not give all keys to the kingdom. Next one, when I trojanize the image poisoning, what you may do with this. On ACR, what you can do, you may enable what's called content trust. If you enable content trust, then you must upload only signed images. And so ACR will trust only to signed images signed by you, not by anyone else. So in this case, I cannot just simply trojanize the image and push it back, even if I have permissions. Next one, it will not really help you with Trojans, but it will definitely increase security. You should also try and run vulnerability assessment, VA vulnerability assessment against your Kubernetes environment and against your containers. And for this purpose, we have free tools from a company called Aquasec, and you may find them on GitHub. There are a few free tools: KubeHunter, KubeBench, and Trevi. KubeHunter, this tool may scan your Kubernetes from outside, so remotely. And that's what attackers can do if they know the address of your Kubernetes. Let me show you this real quick. So I'm going to open Kali. Go to KubeHunter, and I'm going to run KubeHunter. And it gave me some of the ways how can I scan my Kubernetes. So let's say I want to scan just the remote one specific address, and now I need to provide an address. Let me find my Kubernetes and copy this and paste this. Now it will start to analyze Kubernetes from outside. What can be discovered if I'm an external user? And that's what attackers can do if they want to scan your Kubernetes. Nothing was found, of course, because that's Microsoft managed Kubernetes. So no vulnerabilities found. That's called KubeHunter. Also, there are two more tools, KubeBench and Trevi. Those tools will scan your container images. So KubeBench, you will not images. Sorry, KubeBench will scan containers. So you will deploy the KubeBench as the container on the Kubernetes, and it will scan other containers. And Trevi may use container images, may scan container images, or maybe containers. To be fair, I don't remember. On Docker. So that will be on Docker. So this one on Kubernetes, this one on Docker. The same purpose, but one will work on Docker. So you may do it on your developer machine, and KubeBench you may run on Kubernetes itself. But at the same time, we have built-in solution that built into Azure called Azure Defender, and we have VA scanner there built in. So let me show you this real quick. If I go to Security Center and find here Azure Defender, if I enable Azure Defender, which costs money to be fair, you may find here container image scanning, and it says my container image is unprotected. Let's see. Now I can see that I have one image, and this image has two vulnerabilities. And because this is based on Ubuntu, some of the vulnerabilities from Ubuntu itself. Of course, VA will not find Trojan, because Trojan, that's not about vulnerabilities. That's maybe antivirus can find that, but not VA solution. But VA will definitely may find vulnerabilities, and those vulnerabilities may, if you fix them, your images will be much more secure. So you may use built-in solution. You don't really need to. No, you don't really need to use third-party Aquasec if you don't want. Built-in solution is pretty fine. But if you want to test each image separately, well, you may run aquasec as well. Or if you run Kubernetes somewhere else, not in Azure, then aquasec, why not? All right, and a few more things. If you want to avoid installation of different tools in containers, you may avoid root permissions. So design your containers to not allow root permissions. And finally, when I have access to one container, and from one container I jump to other containers, that's called lateral movement. And so we may call it lateral movement. And by default, in Kubernetes and AKS, I can do it. So if you want to stop that, there's a configuration called network policies in AKS. So what you can do, you may tell which container may communicate with other containers, how they can communicate. So you may control the communications between containers inside of the Kubernetes. So that's some mitigations you may use to make your container environment better protected. That was the last informative slide. Before I start to handle your questions and before you get rid of me, I want to tell that yesterday I had another session called Offensive Azure Security. If you missed that, you may check it. Of course, if you like this session, of course, then you're gonna like it. Offensive Azure Security. So if you missed that, check recordings because it should be available. I don't know if maybe it's already available, maybe it will be available later on. But anyway, so I have this session as well. If you wish, go ahead and check it. And of course, if you want to somehow talk to me later on, or just keep an eye on what I'm doing and what new conference I'm speaking, quite often, by the way, people find when you just follow me on LinkedIn. By the way, I don't use Twitter. I'm too lazy for that. So when they follow me on LinkedIn, they find new conferences, find some other great speakers. So if you just connect the conference where I speak, you may find not only me there, but also other very nice people and speakers. So if you want to join, go ahead and do it.